Hello learners, I Dr. Niradhar De, Associate Professor, School of Education, Indira Gandhi National Open University, welcome you all today's video lesson. Today we are going to discuss on one of the very important topic of your online course, that is mean deviation and its interpretation. In our last session we have discussed about quartile deviation, how to calculate quartile deviation, what is the concept of quartile deviation, and how to interpret the result when we are using quartile deviation. And today we are going to discuss the concept of mean deviation and what are the techniques and methods that you have to follow for calculating mean deviation, then further how to interpret the result that you are getting by using mean deviation. Now let us go forward. You see, presently we are in the 14th week of your online course, and we are going through the 14th module. Title of the module is measures of dispersion, and under this module, that is module 14, 4 video lessons are there. First we have already discussed percentile and percentile rank, its calculation and interpretation. Then second video lesson, that is quartile deviation and its interpretation, we have discussed in the last session of this module. Then now we are going to discuss in this session, that is mean deviation, or this is also called as average deviation, and its interpretation. And in the next session we will discuss standard deviation and its interpretation. So friends, this is one of the very important module so far as your online course assessment for learning is concerned, because here we are just understanding, we are just acquiring the skills how to convert raw scores into group score, and further for analyzing and interpreting the result of the students, the school based achievement of the students by using different statistics. Okay. So, just like first we have discussed percentile and percentile rank, then also we have discussed quartile deviation. Today we are going to discuss mean deviation and further standard deviation. And beforehand, in our last module, that is in module 13, we have already discussed measures of central tendency. There we have discussed mean, median and mode. And you know, mean, median and mode is not enough so far as analyzing and interpreting or to provide certain meaning to raw scores or to the performance of the learners. So that is why many a time you will find that the distribution, the distribution is not normal, or you can say the range of the distribution. At the same time, the position of the scores in the distribution may be in different nature. So that is why only measures of central tendency is not enough. So we have to understand about that what are the different other statistics can be used to measure the dispersion. Okay. So keeping in consideration these concepts are discussed in module 14. So friends, now let us focus upon some of the learning outcomes of this module. First of all, after going through this module, you will be able to explain the concept of dispersion, you will be able to explain the concept of mean deviation, then you will be able to calculate mean deviation both in ungrouped and grouped data. Okay. And further, you will be able to interpret the result of a mean deviation. So these are the certain learning outcomes, and I am very much hopeful that after completion of this session, after watching this session, and at the same time after going through the part content of your module relating to mean deviation and measures of dispersion, you will be able to achieve all these learning outcomes, specific learning outcomes of this session. So friends, now let us go forward to understand about the concept of dispersion. I have already discussed when I was talking about average about quartile deviation. I have already discussed the concept of dispersion. So again, let me to recapitulate, because this is also connected with average deviation. So here you see on your screen one table, the score of one table is now visible, and here you see total number of students, that's called as total number of students is n is 8 here, and 8 number of students are there in each 3 groups, group A, group B and group C, and their scores are also given. 8 scores are given in group A, 8 scores are in group B, and equal number of students scores are also presented in group C. Okay. So just like in group A, the scores are 20, 22, 18, 15, 25, 20, 10 and 30, and if you calculate the average score or the mean score of this group, you will find that mean is, you have to add, that's called as summation of x upon n. So you can add all these individual scores, that is 160, and divide it by the total number, that is total number is 8. So 160 divided by 8 is equal to 20, and accordingly in group B also you can add the 8 scores, that is again 160, and total number of cases is here 8. So 160 divided by 8 is equal to 20, and also in group C 8 scores are there, total is, coincidentally total is 160, and total number is 8, and mean score is 20. So friends, you see mean score of all these 3 groups are 20. So when mean scores are 20, can you say that these 3 groups are exactly same? You can't say, because so far as spreadness of the scores are concerned, you can say that the spreadness of the first group, scores of the first group are similar with scores in the second group or scores in the third group. Okay. So you will find that the range of the lowest and the highest score is different in 3 different groups, but mean is same. So that's why I was talking earlier, only calculating measures of central tendency, it may be mean, it may be median, or it may be mode, is not enough. So that's why what you have to do, you have to calculate and you have to analyze data in terms of their position, in terms of their spreadness, that is called as dispersion. So that's why this is the concept of dispersion, and further we can say that it is evident from the data that mean score of all the 3 groups are the same. The earlier data that we have discussed, in all the 3 groups mean score is 20, that is same, but whether the groups are also the same, but we can't say that the 3 groups are same. It means the mean score of 3 different groups are 20, but the spreadness of the scores are different, the range of the scores are different. Okay. And if you calculate the quartile deviation and other measures of variability or measures of dispersion, you will find that this is you will get more and more meaning in it, and many a time we use dispersion when we can say this variation is because of the spreadness, or it is also called as dispersion. Measures of dispersion provide us more meaning of the distribution of the data. I have already said that if you will calculate only measures of central tendency, you will get just minimum, you can put minimum meaning to data, but if you will calculate dispersion, then you can just put more meaning to data. And 4 methods or techniques are there. You can use it for measures of dispersion, that is just like range, quartile deviation, mean deviation and standard deviation. We have already discussed range in our earlier video, then quartile deviation we have already discussed, then we will discuss about the mean deviation. Then further tomorrow in the next session we will discuss standard deviation. So friends, now let us try to understand the concept of mean deviation. You see, mean deviation, that's called as MD. MD, M means mean, D means deviation. So mean deviation, MD, is also called as average deviation. So mean means average. So what you are doing here, you are just calculating the average deviation. First you will calculate deviation of each individual score from the average score, and then after you have to find out the mean deviation. So what is the mean of the deviations. Okay. Then mean deviation is the mean of all deviations of all individual and separate scores in a distribution taken from the mean. So, what you have to do here, you have the individual score and you have already calculated the mean, and you can find out that the deviations of each individual score from the mean. Okay. Deviation of first individual score from the mean, deviation of second individual score from the mean. So, first will be the D1 deviation 1, second will be the deviation 2. So, accordingly you can calculate the deviations. Then after calculating the deviation, further what you can do, you can just take the mean of those deviations. So, that will be the mean deviation. Further we will discuss that how we can do this, what formulas or techniques we can use for calculating mean deviation. Now let us focus upon calculation of mean deviation in ungrouped data. I think you know about ungrouped data. Ungrouped data means when the data is not presented in terms of class intervals, in terms of certain groups, when only individual data is given, okay, raw data is given. So, how to calculate mean deviation in raw scores? The formula that you will use, that is formula mean deviation, that is MD is equal to summation of x modulus upon n. You see x in both the sides of x, you see one line has been drawn. So, that is called as modulus. So, modulus means irrespective of sign. So, if in the deviation, if negative sign will come, so that negative sign will not be considered. Okay. So, here we are not going through the sign, either it is positive or negative, rather what we are doing, we are just calculating, we are just understanding the deviation. Okay. So, deviation, no need of expressing it in minus deviation, rather here we have to calculate the gap. Okay. So, that is why x modulus means it is irrespective of sign, and small x is, here you see small x is x minus m. X is the raw score or the individual score and m is the mean. So, when you will subtract mean from the individual score, that is x, so we can say that that is the deviation. Okay. And this symbol, it is called as sum of, then x is the individual score, here you see x is given, that is the individual score. Okay. And m is the mean of the distribution, x modulus, that is mediation, that is deviation irrespective of sign, I have already said. So, what you have to do here, let us try to understand with one example. Here you see certain raw scores or individual scores are given, just like your score x. How many scores are there? 10 scores are there, 30, 25, 15, 18, 20, 10, 12, 5, 3 and 5. So, here you see 10 individual scores are given, and how you will calculate the mean, because for calculating average deviation in ungrouped data, first you should calculate the mean calculate the mean. So, how to calculate the mean? We know the formula of mean is summation of x upon n. Okay. So, here what you have to do, all the individual scores you have to add all the individual scores, and you have to divide it by 10, because total number of scores are here 10. So, 30 plus 22 plus 15. So, when I add all the 10 scores, I got it is 140, and I have to divide it by the total number of cases or by the n. So, that is why that is 140 upon 10, that is 14. So, 14 is here mean. So, next work is now let us focus upon how to calculate the deviation. You see beautifully this has been explained on your screen. Calculation of x means your deviation. Okay. Calculation of deviation in ungrouped data for calculating mean deviation. Here you see mean is calculated here, that is 14, and these are the individual scores, 10 individual scores, 30, 12, 30, 22, 15, 18, 20, 10, 12, 5, 3 and 5. What you have to do, first you have to see the deviation of any individual score from the mean. So, deviation is 30 here, mean is 12. So, how can you do this? Here you see deviation is x that is x minus m. So, x is the individual score and m is the mean. Let individual score is here 30 and mean is 14. So, what you have to do? 30 minus 14, 30 minus 14 is equal to 16. Then if individual score is 22 and your mean is 18, so 22 minus 18, 22 minus mean score is 14, that is 8. Accordingly, in each individual scores, here 10 individual scores are there. In each individual score, you can calculate deviations. So, that will be the 10 deviations. That is called as x1, x2, x3, x4, x9 and x10. So, these are the deviation 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. And in this way, these deviation 30 to 14, 22 to 14, 15 to 14, 18 to 14, 20 to 14, 10 to 14 you have to calculate. And many a time you will find the deviation is in minus, just like here you see in x6, individual score is 10 and mean score is 14. So, here 10 minus 4. So, 10 minus 4 is 10 minus 14 is minus 4. Okay. So, here deviation is minus 4, but in our formula I have already explained that this is summation of x modulus. So, when modulus sign we are giving two lines in both the sides, it means that is irrespective of sign. So, that is why though it is minus sign, then it will be considered that only positive, that is only 4. 10 minus 14 is equal to 4, especially in this case. Next, now calculation of mean deviation in ungrouped data. Here 10 scores are there, and we have calculated the deviations just like here. First deviation is 16, then 8, then 1, 6, 1, 4, 6, 4, 2, 6, 4 to 9, 11 and 9. So, these are the deviation. What you will be doing? You have to add all these deviations and divided by 10. So, that is 76 upon 10. So, that is 7.6. So, 7.6 is the mean deviation. Okay. So, in this way you can calculate mean deviation in ungrouped data. And now, let us focus upon that how you will calculate mean deviation in group data. So, the formula that can be used for calculating mean deviation in group data, that is formula mean deviation in group data is equal to MD is summation of fx modulus upon n. So, here in ungrouped data only f frequency was there, but now frequency with individual score is also multiplied, and after multiplication its modulus, its signs will be seen. Okay. So, that is why here small x is x minus m, m is the deviation of midpoint of the class interval x from the mean. Okay. And fx is frequency multiplied with the deviation. You have to multiply deviation with the frequency. Mean that is summation of fx upon n. We have to calculate mean here in a long method. In long method, what you have to do? You have to multiply midpoint of the class interval, that is called as x, into f. F is the frequency of different classes. Okay. So, when you will multiply it, you will find a value, and further you have to divide it by 10. So, that will be the mean value of the group, and f is the frequency, x is the midpoint of the class. Now, let us go forward to understand with one example. Here you see calculation of mean deviation in group data. Here in the first column scores are given in class intervals, then midpoint is given in each class interval 10 to 19, midpoint is 14.5, then 22.5, then 34.5, then 44.5, 54.5, 64.5 accordingly, and frequencies are 2, 4, 5, 10, 35, 20. And now what you can do for calculating mean? You have to multiply midpoint of the class interval into frequency, just like 14.5 into 2 is 29, 24.5 into 4 is 28. So, now you got the value of fx, and if you add all these values of fx, you will find summation of fx. and after getting summation of fx, that is 5870, and total number of cases is 100, to get mean, what you can do, you have to subtract, you have to divide summation of fx values, that is 5870 divided by 100. Okay, in the next page this has been done, and here further you have to find out the deviation, that is called as x. So, x is here x minus m, x is the midpoint of the distribution, then m is the mean, m is the mean score. Okay. So, already let us see in the next slide, we have calculated mean, that is summation of fx upon n, 5870 by 100, that is 58.7. So, here what you have to do, you have to just subtract the midpoint from the calculated mean, that means 14.5 minus 14.5 minus 58.7, then again 24.5 minus 58.7. Okay. So, accordingly you can calculate the deviation, because mean is here 58.7. You have to find out deviations from the midpoint, as this is not the individual score, this is a group data. Okay. So, in a group data your calculation should be from the midpoint of the class interval. Then after calculating x modulus irrespective of sign, what you have to do, you have to multiply deviation with the frequencies, that is called as fx. Okay. So, fx has been calculated, and this has also added, that is summation of fx is 1270.40, this is summation of fx. But our intention is to find out the mean deviation, and you know mean deviation, the formula mean deviation is summation of fx upon n, that is summation of fx in the earlier slide we have already calculated, that is 1270.40. So, here 1270.40 upon 8. So, when you will divide it with 8, you will find that decimal point will become nearer of 2 digit. So, that is why it will be 12.704. This is the mean deviation. Mean deviation in ungrouped data and also in group data. Now, let us focus upon the interpretation of mean deviation. First of all, we can say that mean deviation provides a clear picture of the spreadness of the scores, and it makes meaningful of data interpretation. So, it provides a clear picture about the position, about the spreadness of the data, and accordingly we can analyze it. Mean deviation is the simplest measure of dispersion that takes into account all the courses of the distribution. Then further we can say mean deviation is rarely used in modern statistics, however, you will find it in the older literature. And the last interpretation that we can say, mean deviation ignores the importance of plus and minus sign. Therefore, the method does not fulfill the assumptions of algebraic properties, and hence it is not possible to use this method in higher statistics. So, these are the certain concerns that has been addressed here, and at the same time a clear interpretation is given that how mean deviation can be used for better analysis of school based achievement of the learners and reporting the result of the learners. So, friends, just to recapitulate, today we discussed the concept of mean deviation. We started our discussion to understand about measures of dispersion, and further we discussed about the concept of mean deviation. We also acquainted ourselves in the calculation of mean deviation by using ungrouped data, and we also calculated mean deviation by using the group data, and further we also discussed about the interpretation of mean deviation that we use in the teaching learning process, mostly in the assessment activities of schools. Friends, for further queries you can write to me in niradhar@ignou.ac.in. You can make me a telephone call. My number is 2994 You can visit my Facebook account, my YouTube channel, and my Twitter handle. You will find many such good videos relating to education, relating to teacher education are uploaded in the YouTube, and all these videos are available in the Facebook. You can take the benefit of it. Thank you.